Hey guys, welcome back to my channel once again. Today I was gonna move on to breadth first search, but then I looked at some more examples and I found a really interesting one. Medium level difficulty, so quite challenging compared to the one that we did yesterday. Um, and yeah, I wanted to do this. Um, I didn't figure it out myself. I had to go through the solution after trying it out myself. But the implementation itself, I did it myself. But the intuition, I couldn't think of it myself. Yeah, let's see the question first. So the question is maximum difference between node and ancestor. So given the root of a binary tree, we have to find the maximum value v for which there is a different node A and B where V equals to A dot val, so value of A minus value of B, and A is the ancestor of B. So basically ancestor means that it's one of its parents. Um, so node A is an ancestor of B if either any child of an A is equal to B or any child of an A is an ancestor of B. So yeah. Mm, So as you can see from this example, it's visualized here as a tree. So the maximum difference is, uh, so what there's a calculation done, 8 minus 1. So 8 is like the absolute root of this tree. Then 1 is like the left side leaf. So how are you gonna approach this question? Um, so tree is traversing a tree is all about recursively applying the function, right? And in order to recursively apply a function that would traverse this tree and then update some kind of value every time it approaches a node um, with the maximum value, right? We have to update it, constantly update it, and then compare it with uh, the previous value. Because if a value is bigger than the one previous, it means that it's a maximum of that current state. And it keeps on getting updated, 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 and then at the last, we're gonna find the absolute maximum difference. So what has to be defined? The answer has there has to be some kind of variable. Okay, I'll name it answer. Answer that has to be defined. That has to be updated. Also, inside this answer, because we are fine, in order to find a difference, it's maximum minus minimum. So obviously the maximum and minimum has to be constantly updated as well as we traverse the tree. Um, so uh, we need to use a recursive helper function that performs a depth first search on the binary tree. So this is not enough. We need to use uh, a function that could be recursively applied. Um, and this this mi and mx, these parameters will um, keep track of the minimum and maximum value respectively. So 1 second. So at each node, we're gonna compare and update the answer with the absolute difference of the current node's value, which is root dot val, right? Because value is already defined here within a class. And also the minimum and maximum, like I just said, seen so far during the path from the root. So we're gonna do this by maximum of, so this is like the exoskeleton of the code that we're going to write. Maximum of answer and absolute of minimum minus the root dot value, and then the absolute of maximum minus root dot value. So after updating answer, we also update the minimum and maximum for the recursive calls on the children nodes, setting minimum and maximum to the minimum and maximum of that current no, of all the nodes along that path, the smallest and largest. And recursive calls are then made to continue the depth first search traversal on the left child, and then we're going to move on to the right child, like we saw yesterday. So the main function will initialize the variable to the variable as in variable answer to 0 initially, and then call the DFS, the recursive helper function, right? So how are we gonna do this? I think it's best to define the current difference and maximum difference inside the recursive helper function that we're gonna set later on. So current diff should be max of absolute minimum value minus node val, right? Minimum value minus the root value. So if it's from 8 to 3, then that should be 8 minus 3. No, 3 minus 8. Yeah. Minimum is 3. Then the root value is 8. And then, so the absolute of that would be 5. And then the absolute of the same thing, but in this case, maximum value that we're going to define later, and node val. So that will be the current difference at a certain node. What will be the maximum difference? The maximum difference will be the max of, because we're constantly comparing the difference of the previous calculation and the current difference, right? So that will be max diff, another recursive call here, and then current diff. Now we're gonna define the function that helps us calculate the maximum function and minimum function. So that would be not the define, but helps us update the maximum and minimum. So in this case, new minimum will be the minimum of minimum value and node val, node dot val, node dot val. And new maximum will be max of max value, then node val. So that would be the same thing. The node val is the root value and then maximum value, and then we're iteratively calling the max function in between the previous max value and the root value to check if the new value is bigger or smaller than the previous one. Okay, so that was the updating of minimum and maximum. And now let's let's define the DFS function here. So skeleton should be diff DFS. We need node. So a node and minimum value and maximum value, because we have to keep on updating the minimum value and maximum value. And of course the root. This should be indented to the right side. Yeah. We also have to define the edge case. So that would be if node is empty, then return none, return nothing, and then we call this. Yeah. And so this has to always be in the start of the recursive function. Now we recursively call DFS for the left and right column. So that will be the first search, the recursive helper function that we initially defined. Node left, because we start from the left side of the tree. New min and new max. We do the same thing for the right side. So that will be node right, new min, and then new max. Yeah. Now we have to initialize also the max difference, which will hold the result. So that will be outside the scope, max difference is 0. Yeah, we can put this here, right? Now we have to start DFS from the root, from its value as both initial min and max. So that would be DFS root dot val root dot val. So yeah, initialize the left and right node, and later we return the maximum difference found. So that would be return max difference. Let's try it. Okay, can I access? Oh yeah, we have to allow it to. How do I go? Yeah, so in this case, that will be non-local, right? So we have to put non-local here, non-local max difference. Let's try this again. Okay. which we still cannot access the non-local, the local maximum. Maybe this has to max difference. Oh, wait. Max difference. I don't know why I put max diff there. Oh, I think it's correct. Yeah, there's submit button, so I guess it's correct. Accepted. Yes. Mm, yeah, I think it's correct. Yeah, for case two as well, it's showing the expected output. Yeah, so that was it for today, guys. It was quite challenging. Uh, I don't think we need more exercises for this for now. Maybe later, when we go through all the algorithms, I'm going to come back and then um, do some tree exercise for sure because it's one of the questions that come out most. Um, and yeah, it will be beneficial for me to refresh the memory. But yeah, thank you guys all for listening. And if you guys have any questions, just put down in the comments. And yeah, see you guys tomorrow.